What's up, math? I hope you're all having a great day and welcome back to my channel. This, of course, is another episode of reverse engineering the calculations of other YouTubers. This time we're looking at YouTube commentator Danny Gonzalez.
What's up, Greg, and welcome back to another episode.
What's great about Danny's videos is instead of just doing the lazy thing of sitting at home and talking about other people's videos, he does that, but also gets involved. He goes out and does some ridiculous projects. In this case, he was looking at the phenomenon of giving away Teslas. There's been this thing where big YouTubers will give a Tesla as a surprise gift to a friend or a fan or a family member, and they film the whole thing. It's great content. Danny was curious to know how the financials behind that actually work, and we're going to get into their calculations. But to do it properly, Danny decided they themselves would have to give away a Tesla.
Can giving away a Tesla to some random person end up doing more harm than good? Let's find out. Because I'm giving away a Tesla, baby.
And if Danny can do it, I mean, I've been inspired to give that a go as well. Surely, of all people, my viewers want to go electric and they appreciate speed, efficiency, and excellent design. So I'm going to give away a Casio calculator to, I'm kidding, I'm not going to give this away. I don't give stuff away. I give away knowledge on this channel. So I'm going to give away, for free, a Tesla equation for giving away a Tesla.
This video is sponsored by Jane Street, who not only support my channel, check out their programs if you're considering a career in finance or software development, but they're supporting my one-day maths extravaganza for high school students, Maths Fest. Details at the end of the video.
Here's how the YouTube Tesla giveaway traditionally works. You have a YouTuber, which in this case is Danny, who it seems I have inadvertently stabbed in the neck. The YouTuber buys a Tesla. And because this normally happens in the United States of America, the sales tax is listed totally separate to the purchase price for who knows what reason. Of course, sales tax can vary state to state, even city to city. So the YouTuber buys the car, pays the sale tax on the car, and then gives the car to some random mystery recipient who are very excited that they've just been given a free Tesla. Except it's not a free Tesla because sales tax is not the only tax involved. There's income tax, and in the US of A gift is considered income. So this poor individual, when they file their taxes for this year, they have to list the value of the Tesla, which is tens of thousands of dollars, as their income, and then they've got to pay whatever tax rate that falls into on that income. So they can be liable for tens of thousands of dollars of tax. So it's not a free car, they've got to pay a lot of money. And the conclusion that Danny comes to is this system is fine if you want to give a Tesla to someone who's already rich and could probably buy their own Tesla. But if you want to give it to someone who's a worthy recipient who would benefit getting a Tesla that they otherwise couldn't afford, they can't afford it because they haven't got the cash flow to pay the income tax. And in most cases, you can't ask to take the cash equivalent. The contract says you got to take the Tesla. So this poor person may not have the cash flow to receive a free car. It's possible they can't afford a free car. This problem's been around for a long time in game shows. Famously, they give away cars. I mean, you get a car, you get a car. Sadly, you get tax implications, you get tax implications. Everybody gets tax implications. So what Danny decided to do was to mix it up. They were not going to buy the Tesla themselves. They were not going to pay the sales tax. Instead, they were just going to get a big lump of money and give it to them directly. Here's the new situation. Danny gets a big pile of money equal to the value of a Tesla. They give that to the winner, who can then spend it on a Tesla. But this person still has to pay the sales tax on the Tesla and their income tax. So this amount of money equal to the Tesla is insufficient. They're going to have to give them a little bit more money. So we'll add on a bit more money here on the way through. There we go. The problem now is if this is enough money to cover the sales tax and the income tax, this money is going to get taxed. There's going to be income tax on this. So what we're going to have to do now is get a little bit more money to cover the income tax on the money that was for the income tax. But the problem now is, of course, this little bit of extra money is also going to be taxed, and the next bit will be taxed, and the next bit will be taxed. So Danny had to work out exactly how much money is necessary, so after tax, it all lines up.
So we're gonna have to factor in sales tax, which I think will be around 3.6 or 7K. Income tax, which will be about 11.7K. I don't know why I made that K lowercase and these ones uppercase.
You can see on the screen though that the actual value of the car, if we want to be exact, was $48,990. We now have to reverse engineer what sales tax and income tax Danny was using. I'm pretty confident that the sales tax that Danny was using was calculated at 7.5%. So I just basically tried to reverse engineer this step. 7.5% is the sales tax, I believe, in California. So that does kind of line up. And if you run the numbers, quote unquote, correctly, the sales tax is $3,674. So I guess Danny has just rounded down to 3.6 from there. For the income tax, Danny has used a rate of 24%, which is the income tax you pay for all income between about $86,000 a year and $165,000. So I guess that's kind of a worst case scenario if people get bumped up into that bracket. I mean, you only pay tax on the income in each bracket, of course. However, I guess he's figured worst case, all of the value of the car could be in that bracket. And in that case, the exact tax you would pay would be $11,758. So again, I think this lines up nicely. Danny will have calculated this and then rounded it down to be 11.7. So far, so good.
But now since I'm giving them this money, I have to account for the taxes on this money also, which we're estimating to be 3.7K. And this could go on forever. Like, since this money is also gonna get taxed, I have to give a little bit more, and a little bit more, and a little bit more. But that's too much math, and the number that we come to is 68K. But you know what? Let's just make it a nice even number and change it to 70,000 smackaroons.
This is where we have to work out the tax on the extra money that was given to cover the taxes. So Danny said that comes out to be 3.7K. Of course, I double checked. If you add together these two exact figures I worked out, and then you tax them at the 24% rate, it comes out to $3,704. So that's incredibly close. So Danny has done all the working out so far pretty correctly. This is where it cascades, because as Danny points out, you have to pay the tax on this, then the tax on the money to cover that tax, and the tax on that, and then all the way down. Each time you're paying 24% of the previous value. And he says that could go on forever. Indeed, it does. That's true. He also says that's too much math.
That's too much math.
And that is incorrect. It is the right amount of math. However, Danny hand waves it away. And for the record, Danny has a degree in computer science. So I don't mind dunking on him here. He should know what he's doing. He says the figure they came to is just 68K. But interestingly, 68K is just the sum of these four numbers. If you add these ones together, you get exactly 68.0K. So they haven't done any extra working out behind the scenes. They've just summed those and then rounded it up to 70K. But is that correct? Little reminder, Danny got to 68K, which was then rounded to be 70K. We're going to do it properly, and we're going to do it in general to start with. So we have the cost of the car, C. We've then got some sales tax at, I don't know, let's just call that S. And then we've got some income tax rate, which I'm going to call R. We want to take all of this and somehow give us T, the total amount of money that Danny has to give the winner so they can afford everything else. First up, what is just the cost of the car, including sales tax? So if you were to have tax already included in the price, well, that's going to equal whatever the cost of the car is plus the sales tax, which we could write as plus whatever the sales tax rate is times the cost of the car, but that's just, it's the cost of the car times 1 plus whatever the sales tax is, which comes out to a grand total of $52,664. So to be honest, that is just the cost of the car, including tax. We'll use that from now on. For all of this, we've been talking about the income tax rate, which is 24%, which actually, you know what, I'm going to write that as 0.24. It's a bit easier for the calculation. We keep talking about 24%. That's the percentage that goes to the government as tax. We actually don't care about that. What we really care about is how much do we get to keep. And if you're giving away 24%, you get to keep 76%. So really, we want to look at how much of the money that Danny gives the winner do they get to keep? And the answer is 0.76, which for the record, what we've done there is just 1 minus the tax rate. That's the keep rate. That's the non-taxed rate, which in our case, 76%. To put that all together, Danny wants to give some total amount of money such that if you multiply it by the keep rate, which we worked out to be 0.76%, then you get the amount of money you need, the cost of the car, including sales tax, which we worked out a second ago. So we can swap that in right now. So we can just rearrange to work out what T is. In fact, we're going to divide both sides by 0.76. So if we put that over there, and we pop that over there, we divide it by 0.76, and that's our answer. And that gives us $69,295. So I'm prepared to call that the equivalent of, let's say it's roughly 69K, but to be safe, we'll round it up to 70K. So, I mean, I got to give it to him. It was hand waving, and he missed some bits, but he did get rounded up to the correct answer. And you know I want to do this in general, so we're going to swap this out. So that top amount there, that's the cost including sales tax, which is the original cost times 1 plus the sales tax rate. And then what we did was we divided it by the keep income rate. So you divide that by 1, subtract the income rate. So that's your Tesla giveaway equation. And that's what I'm giving away for free. Everyone can have that. And this is just information in your mind. Government can't tax that. Okay, I'm just going to move this up in the corner here now. So we're just going to bear in mind, we worked out that the total you have to give equals the combined cost including tax divided by 1 minus the rate. You know, I feel like I'm doing Danny a bit of a disservice. I really like the way they worked it out. So even though this way, the correct way, this is what you would get if you asked like a mathematician or an accountant or someone with a computer science degree to work it out algebraically. That's the proper way to do it. However, Danny's way of having like the infinitely many, you pay the tax on the tax, you pay the tax on the tax on the tax, you pay all the way down. I think this is a more intuitive way of understanding it. That's a much more interesting way to think about it. And I suspect there's a way we can combine this way with my way.
I didn't fully know what I was getting myself into at this point.
So here we go. We're going to formalize Danny's infinite series. So Danny was saying that the total cost equals the cost of the car including the sales tax plus the cost of the car including sales tax times whatever the income tax rate is. So 24% of what you've already got to cover that. But now you've got to pay tax on this. So it's plus the cost of the car, including sales tax, times the tax rate, times the tax rate. So that's the rate squared, plus the cost of the car, including sales tax, times the rate cubed, and so on. And what we've got here is a geometric series. I can bring this out the front. It's the cost of the car, including sales tax, outside of 1 plus r squared plus r cubed plus r to the 4, on and on and on. And as Danny correctly said, this could and indeed does go on forever. But mathematicians don't fear things going on forever. They love it. There's more math to do. And there's never too much math. We can do math with infinitely many things, but I'll be honest, we do have to wrangle it into a nice finite term. So somehow we have to get rid of the fact that there's infinitely many of these. And what we're going to do is cheat slightly. So I'm going to write under here a new equation. This is the total times the tax rate. Ignore y for a moment, but the knock-on effect is that we've now got the total including the sales tax times, and then on this side I have to multiply every single thing by the tax rate. So 1 becomes the rate, plus r becomes r squared, plus r squared becomes cubed, plus r to the 4, plus r to the 5, onwards. And so now, every single one of these terms in here is now one more r than before. Imagine now, if you will, we take the original total that Danny needs to hand over. We then subtract this new ridiculous one, which is the total times whatever the rate of tax is. It equals the total cost of the car, including sales tax, times, well, it's all of these subtract all of these. And so what we need to do now is, well, actually they cancel out, because if we got an r here and we subtract that r, they're gone. We've got an r squared and an r squared, they're gone. R cubed, gone. All the way, in fact, all of these cancel out and we're left with 1. Huh. Well, that's handy. And we can now rearrange that because we've got a t out the front here of, well, that's t out the front of 1 minus r equals, we don't need that 1 there, that's just that. And now, if we were to move this over to the other side, we have got that. We have recreated the intuitive formula that I would have used by following through the logic that Danny used and then just working out what it converges to. You can get exactly the same answer 2 different ways. Now that's the right amount of math. One tiny disclaimer, which is often the case with a free giveaway, so don't complain. This only converges, that is, approaches a nice set, leveled off value for certain values of r. And that kind of makes sense if you think about it intuitively. If you've got infinitely many things you're adding together, well, you might think that's going to be infinitely big. Like if I'm always adding something else forever, if I never stop adding on things, surely the total is going to be huge. However, even though you are adding on infinitely many of them, they're getting small enough fast enough. Or rather, these terms get smaller faster than they're being added on. That's a terrible way to say that. But basically, if r is between 0, well, it can be equal to 0, it can be bigger or equal to 0, r, and less than 1, these terms will get small enough, fast enough, that it doesn't matter. There are infinitely many of them. They will still approach a nice set value. Actually, if r was 1, you can see we're going to have problems because we're dividing by 0. And then that would explode. And that's not covered by the warranty. But if we have r between there, I mean, r bigger than 1, that would be a tax rate of more than 100%. Which, I don't know. Would you ever need above 100%? I feel like even if that's what you wanted, there'd be a better way like to change the lower brackets. But maybe there are situations where you could have a tax rate above 100%. I know you can have tax rates below 0, and I think there are some interesting things that happen if you have certain tax brackets with a negative tax rate. Different conversation for a different channel. But in general, as long as you keep it in this range, which by definition pretty much all tax rates are, this converges. And so this formula, you can rest assured, will always work as long as you keep it within the recommended range. Unlike a Tesla, there is no long-range version of this formula available. Thanks to the sponsor of this channel, janestreet.com/joinjanestreet/rprograms. And Jane Street don't just sponsor this video, they are the principal sponsor of my channel. Regular viewers will know all about them. But if you're new here, Jane Street use mathematics to solve complex problems in the financial world. Problems that complex, or more. I mean, always more. And way more. In fact, sorry to everyone watching this for whom a convergent geometric series wasn't exactly groundbreaking. I just thought it was amazing. It popped up in such an unexpected place. And that's what Jane Street are all about. Finding maths in unexpected places and using it for incredible insight. If you want to learn more about what it would be like to work with that sort of an organization, you can check out all their programs. I did mention these in a video right before Christmas. However, now a lot of them are accepting applications. The New York office might be accepting them now, at least will very soon, and I'm pretty sure 2 of them in the London office and 1 in the Hong Kong office are all taking applications. You can go along. I know it says join Jane Street. If you're just interested, you can learn more about them. And this is pretty exciting. Jane Street not only sponsoring this video and my channel, they're now sponsoring Maths Fest. This is the all-day maths extravaganza. I'm putting it on at the Royal Institution this year. Some of the best maths speakers in the world will be there talking about how you can use maths, and we're now going to have a live stream which is free for any school in the UK who haven't got the budget for it. Jane Street have got you covered. I mean, everyone else in the world, you're welcome to join in. We might ask for some money, but if you're a UK school, we can hook you up for free. Thanks to janestreet.com/joinjanestreet/our programs. Check them out. Thank you so much for watching. I had a huge amount of fun making this video. Thank you to my regular viewers who put up with something a little bit different than normal. Thank you to Danny Gonzalez for making the original video that inspired this. If you want to see more of Danny, then go to www.youtube.com/drewgooden1. And if you are new to my channel, please do subscribe and turn on notifications to join Math. Math is the army of viewers on YouTube with the greatest value of DRME over DT. So subscribe, turn on notifications. Next time, I will show why the Logan brothers scale exponentially rather than in a linear fashion.
This video is over now. You'll find something else to watch. Go watch one of Danny's videos. I know we did a lot of sums, but you can't stay on this end screen as time approaches infinity.